Hello everyone. So in today's class, we're going to discuss NCERT section 9.4.3 with example 14 to 18. So in this lecture, we will focus on linear differential equation. By the end of this lecture, we will understand how a linear differential equation look like, what is its standard form, and what is the method to solve a linear differential equation. Okay, we also solve some example so that we can clearly understand how to apply this method to solve a linear differential equation. Okay, so a differential equation of the form dy by dx plus py is equal to q, where p and q are constant or function of x only, is known as a first order linear differential equation. Okay, so if there is a a differential equation of the form dy by dx plus py is equal to q is called linear differential equation, where p and q are either constant or function of x only. For example, dy by dx plus y is equal to sin x. So here when we compare it with your general equation, that is dy by dx plus py is equal to q, p is 1 and q is sin x. So p is constant and q is a function of x only. The second example is dy by dx plus 1 by x into y is equal to ex. Okay, so here p is 1 by x and y and q is e the power x, and both p and q is a function of x only. So this given differential equation is a linear differential equation of the type dy by dx plus py is equal to q. The third example is dy by dx plus y by x log x is equal to 1 by x. This example is more complex. Okay, as here the value of p is 1 by x log x and q is 1 by x. Both are function of x only. So this differential equation is a linear differential equation. Okay, first order linear differential equation. Another form of first order linear differential equation is dx by dy plus p1x is equal to q1, where p1 and k1 are constant of function of y only. In the first type, in the first form of the linear differential equation, there are dy by dx plus p1y is equal to q, where p and q are either constant or function of x only. But in this second form, that is another form of linear differential equation, there is dx by dy plus p1x is equal to q1, and here p1 and q1 are either constant or function of y only. For example, first example is dx by dy plus x is equal to cos y. Okay, and when we compare it with your general form, p1 is 1 and q1 is cos y. So p1 is constant and cos y, that is the value of q1, that is a function of y only. So this given this differential equation is a first order linear differential equation of the form dx by dy plus p1x is equal to q1. Second example is dx by dy plus minus 2 by y into x is equal to e square into y square into e the power minus y. Okay, and here the value of p1 is minus 2 by y and q1 is y square into e the power minus 1. So both p1 and q1 are only function of y. So this is a linear differential equation, first order linear differential equation of the form dx by dy plus p1 x is equal to q1. Okay. So now we see what is the method how to solve a first order linear differential equation of the type dy by dx plus p1 py is equal to q. Okay, so if we have a linear differential equation of the type dy by dx plus p1 is equal to q, so what is the procedure to solve this differential equation? So okay, so multiply both sides of the above equation by a function of x, say gx, to get gx into dy by dx plus p into gx into y is equal to q into gx. We just multiply the given differential equation by any function of x, let's say gx. Now we choose gx in such a way that RHS become a derivative of y into gx. So we write the gx into dy by dx plus p into gx into y is equal to d by dx derivative of y into gx. So we have to choose gx in such a way that RHS become derivative of y into gx. So when we differentiate y into gx with respect to x, we get gx dy by dx plus y into g dash x. We just apply the product rule of differentiation. That is, whenever we differentiate a product of two functions, like we differentiate uv with respect to x, so differentiation of uv with respect to x is equal to u into differentiation of v with respect to x plus v into differentiation of u with respect to x. Okay, so finally we get p into gx is equal to g dash x. So the value of p is g dash x by gx. Now we integrate both sides with respect to x. We get integration of p dx is equal to integration of g dash x by gx into dx. And we have a property formula for integration, that is integration of fx by f dash x dx is equal to log mod fx. So using this we have integration of p into dx is equal to log gx. So gx is equal to e the power integral of p dx. Okay, so to solve a linear differential equation, at first we what we do is just multiply gx. We just multiply by gx. Okay, and now we have to choose gx in such a way that RHS become derivative of y into gx. And when we apply the condition, when solve this condition, we get the value of gx as e the power integral of p dx. So on multiplying this equation by gx, this function gx is equal to e the power p dx is called integrating factor of the given differential equation. Okay, so just substitute the value of this integrating factor, that is e the power integral of p dx, in the equation. The differential equation, when we multiply by gx, we get an equation that is gx into dy by dx plus p into gxy is equal to q into gx. So now we substitute the value of gx into this equation. We get e the power integral of p dx into dy by dx plus p into e the power integral of p dx y is equal to q into e the power integral of p dx. Okay, and if you carefully observe the first term, the LHS part, this is a differentiation of y into e the power integral of p dx. When we apply the product rule, into y into e the power integral of p dx. For differentiation, we get e the power integral of p dx dy by dx plus p into e into integral of p dx y. So now we integrating both sides of above equation with respect to x, we get y into e the power integral of p dx is equal to integration of q into e the power integral of p dx dx. Okay. So y is equal to e the power minus integral of p dx into integration of q into e the power integral of p dx plus c, and which is the general solution of the given differential equation. So to find a solution of a linear differential equation, at first write it into the standard form, that is dy by dx plus p y is equal to q. Okay, and then we have to calculate integrating factor, and that integrating factor is given by e the power integration of p dx. And when we have an integrating factor, we just apply this formula, that is y is equal to e the power minus integral of p dx into integration of q into e into integration of p dx plus c, to find a general solution of that given differential equation. Okay, so write the given the steps are: write the given differential equation in the form dy by dx plus py is equal to q, where p and q are constant or function of x only. Then find the integrating factor, that is integrating factor is equal to e the power integral of p dx, and then write the solution of the given differential equation as y into integrating factor is equal to integration of q into integrating factor dx plus c. That is a formula to calculate general solution of a linear differential equation. Now, if your given differential equation is in another form, that is dx by dy plus p1x is equal to q1, where p1 and q1 are either constant or function of y only, then integrating factor is given by e the power integration of p1 dy, and the solution of the differential equation is given by x into integrating factor is equal to integration of q1 into integrating factor dy plus c. The first example is, find the general solution of the differential equation dy by dx minus y is equal to cos x. So this equation is a linear differential equation, first order linear differential equation of the form dy by dx plus py is equal to q. So by using this step, just try to solve. The given differential equation is a dy by dx minus y is equal to cos x, and given differential equation is of the form dy by dx plus py is equal to q, where p is minus 1 and q is cos x, and p is constant and your q, that is cos x, is a function of x only. So in the second step, now we have to calculate the integrating factor, and that integrating factor is e the power integral of p dx, as the value of p is minus 1, so integrating factor is e integral of minus 1 dx, that is integral e is equal to integration of minus dx, that is minus x, so integrating factor is e the power minus x. Now multiply both sides of equation by integrating factor, and as we multiply by gx, and gx is your integrating factor, so we multiply by the integrating factor, that is e to the power minus x. We get e to the power minus x dy by dx minus e to the power minus x y is equal to e to the power minus x cos x. We can directly apply the formula to find the general solution, but we do this step so that we can understand how we get that formula. Okay, so e to the power minus x dy by dx minus e to the power minus x y is equal to e to the power minus x cos x. So the LHS part can be written as d by dx into y into e to the power minus x. Okay, so we can observe that when we differentiate y into e to the power minus x by product rule, we get e to the power minus x and differentiation of y with respect to x, that is dy by dx, into plus y into differentiation of e to the power minus x, that is minus into e to the power minus x. So we get exactly the LHS part, that is e to the power minus x dy by dx minus e to the power minus x y. So on integrating both sides with respect to x, we get y into e to the power minus x is equal to integration of e to the power minus x cos x dx plus c. Now you have to calculate this integral, that is integration of e to the power minus x cos x dx. So let's suppose I is equal to integral of e to the power minus x cos x dx. And to integrate this, we apply the by parts rule. And just recall the formula of by parts, that is integration of u into v dx is equal to u into integration of v dx minus integration of differentiation of u with respect to x into integration of v dx. Okay, so to integrate e to the power minus x cos x dx, we apply the by parts rule, and for that we have to choose u and v. So we choose u and v according to the formula. As in this formula, we have to integrate v and differentiate u. So we choose u is equal to cos x and v is equal to e to the power minus x, because the integration of e to the power minus x is easier than cos x, and we know by the elect rule. So just substitute this value of u and v into the formula of by parts. So integral is equal to u, that is cos x, integration of v dx, that is integration of e to the power minus x dx, minus integration of differentiation of cos x, that is d cos x by dx, into integration of e to the power minus x dx. And we know that integration of e to the power minus x dx is equal to minus into e to the power minus x, and differentiation of cos x is minus sin x. So using this, we have cos x into e to the power minus x by minus 1 minus integration of minus sin x into minus e to the power minus x dx. That is I is equal to minus cos x into e to the power minus x minus integration of sin x into e to the power minus x dx. So here again apply multiplication rule of integration in integration of sin x into e to the power minus x dx. So just apply the by parts rule, that is integration of u v dx is equal to u into integration of v dx minus integration of du by dx into integration of v dx. So choose u is equal to sin x and v is equal to e to the power minus x according to this formula, as the integration of e to the power minus x is easier than comparing to integration of sin x. So we get I is equal to minus cos x into e to the power minus x minus sin x integration of e to the power minus x dx minus differentiation of sin x by dx into integration of e to the power minus x dx into dx. And we know that integration of e to the power minus x is minus into e to the power minus x, and differentiation of sin x with respect to x is cos x. So using this we have I is equal to minus cos x into e to the power minus x minus sin x into minus e to the power minus x minus integration of cos x into minus e to the power minus x dx. So I is equal to minus cos x into e to the power minus x and plus sin x e to the power minus x minus integration of cos x into e to the power minus x dx. And since the integral of cos x e to the power minus x is considered as I, so we just replace integral of cos x e to the power minus x dx as dx by I. So we get I is equal to minus e to the power minus x cos x plus sin x e to the power minus x minus I. So now we solve and we get 2i is equal to sin x minus cos x into e to the power minus x. So I is equal to sin x minus cos x into e to the power minus x by 2. That is integration of e to the power minus x cos x dx is equal to sin x minus cos x into e to the power minus x by 2. So substituting this value in this equation, y into e to the power minus x is equal to integration of e to the power minus x cos x dx plus c. So now we have the value of integration of e to the power minus x cos x dx. So just substitute the value. We get y into e to the power minus x is equal to sin x minus cos x by 2 into e to the power minus x plus c. Therefore, the general solution of the given differential equation is y is equal to sin x minus cos x by 2 plus c into e to the power x, and that is the general solution. So the constant term represent the family of curves which satisfy the given differential equation. Okay. So to solve a linear differential equation, the main task is to find the value of integrating factor, and when you have the value of integrating factor, you can just apply the formula to get the solution of the differential equation. Okay. So next example is example 15. So find the general solution of the differential equation x dy by dx plus 2y is equal to x square. So at first write this into the standard form of the linear differential equation. Then we find the integrating factor, and then by using the formula to calculate a general solution of differential equation, we calculate the solution of this differential equation. So the given differential equation is x into dy by dx plus 2y is equal to x square. So dividing both sides of the above equation by x, we get dy by dx plus 2 by xy is equal to x. So which is a linear differential equation of the type dy by dx plus py is equal to q. So on comparing, we get p is equal to 2 by x and q is equal to x. Now, first step is complete. In the second step, we have to calculate integrating factor, and the integrating factor is given by e to the power integral of p dx. So as the value of p is 2 by x, so just put the value of p. So integrating factor is e integral of 2 by x dx. So integrating factor is equal to e to the power 2 log x, as the integration of 1 by x is log x. So we get e to the power log x square. By the property of logarithmic, that 2 log x can be written as log x square. And whenever we have e log fx, so we get fx. So e to the power log x square become x square. Therefore, solution of the given differential equation is solution of the given differential given by y into integrating factor is equal to integral of q into integrating factor dx plus c. So in the first step, at first write the given differential equation into the standard form, compare with the general form to get the value of p and q, and by the value of p, calculate the integrating factor, that is your e to the power integral of p dx. And when you have the value of integrating factor, just apply this formula to get the general solution, and that formula is y into integrating factor is equal to integral of q into integrating factor dx plus c, where integrating factor is x square and q is x, and the value p is 2 by x. To substitute this value into the formula, we get y into integrating factor x square, so y into x square is equal to integration of q is x into integrating factor x square, so x into x square dx plus c, so it becomes integration of x cube dx plus c. And we have a power rule of integration, that integration of xn is x to the power n plus 1 by n plus 1. Therefore, the general solution of given differential equation is y is equal to x square by 4 plus c into x to the power minus 2. Okay, so that's how we can calculate a general solution for a differential for a first order linear differential equation. Okay. So next example is find the general solution of the differential equation y dx minus x plus 2y square dy is equal to 0. So we need to find the general solution of this differential equation, and as this equation is first order linear differential equation, and at first we write this differential equation into a standard form of linear differential equation, that is dx by dy or dy by dx. Okay, and then we calculate its integrating factor and then substitute into the formula to get a general solution. Okay, we have given y dx minus x plus 2y square dy is equal to 0. That's your given differential equation. So it can be written as dx by dy minus x by y is equal to 2y. Okay, we just simplify the given differential equation and transform it and rewrite it as in the standard form, that is dx by dy minus x by y is equal to y. We do algebraic manipulation. Okay, so it is of the form dx by dy plus p1x is equal to q1. So when we compare it with this standard form of differential, it is another form of first order linear differential equation, as here dx by dy plus p1x is equal to q1. So here p1 and q1 are either constant or function of y only. So when we compare, we have p1 is equal to minus 1 by y and q1 is equal to 2y, and both are function of y only. So when you have value of p, now we can calculate the integrating factor, and the integrating factor is given by if is equal to e the power integral of p dy. Okay, so as the value of p is minus 1 by y, so integrating factor is equal to e the power integral of minus 1 by y dy is equal to, so when we integrate minus 1 by y dy, we get minus log y. And when we apply the property of logarithmic, we can write it as e the power log y minus 1. And as we know, e the power log fx is fx. And as the value of fx is here 1 by y, so we get integrating factor as 1 by y. Hence, the solution of the differential is given by x into integrating factor is equal to integration of q into integrating factor dy plus c. So carefully observe that if the given differential equation is of the form dx by dy minus dx by dy plus p1x is equal to q1, then we apply this formula. In the previous two examples, the given differential equation is of the form dy by dx plus p y is equal to q, where p and q are either constant function of x. But in this example, the differential equation is of the form dx by dy plus p1x is equal to q1, where your p1 and q1 are function of y only. Okay, so here we apply this formula, that is x into integrating factor is equal to integration of q into integrating factor dy plus c. But in previous example, the formula is y into integrating factor is equal to integration of q into integrating factor dx plus c. Okay, and here the value of integrating factor is 1 by y and q is 2y. So just substitute this formula, these values into this formula, we get our general solution of this differential equation. That is x by y is equal to integration of 2y into 1 by y dy plus c. So you get x by y is equal to integration of 2 into dy plus c. And we know that integration of xn dx is x to the power n plus 1 by n plus 1, where n is not equal to minus 1. So when we apply this formula, we have x by y is equal to 2y plus constant of integration. So just simplify, there we get the general solution of the given differential equation, that is your x is equal to 2y square plus cy. And as it is a general solution, because there is a constant of integration, so this solution represents a family of curves which satisfy the given differential equation. Okay. Next example is find the particular solution of the differential equation dy by dx plus y cot x is equal to 2x plus x square cot x, where x is not equal to 0, given that y is equal to 0 when x is equal to pi by 2. So what is the difference in this example is that we have to calculate the particular solution. Okay, and to calculate a particular solution of the differential equation, at first we have to calculate general solution, and then we have to apply some initial condition to find the value of c, and when we substitute back the value of c, we have a particular solution. Okay, so let's find its general solution. At first, its general solution. So we have given dy by dx plus y cot x is equal to 2x plus x square into cot x, where x is not equal to 0. And the given equation is a linear differential equation of the type dy by dx plus py is equal to q. So when we compare, we get p is equal to cot x and q is 2x plus x square cot x. And we know that is integration of cot x is log mod sin x. So you use this formula to get integrating factor. That is integrating factor is given by e the power integral of p dx, and the value of p is cot x. So integrating factor is e the power integration of cot x dx. And as we know, integration of cot x is log sin x, so we get e the power log sin x. And we know that e the power log fx is fx, so e the power log sin x is sin x. Hence, the solution of the differential equation is given by y into sin x is equal to integration of 2x plus x square cot x sin x dx plus c. We just apply the formula, that is y into integrating factor is equal to q into integrating factor dx plus c. And here the value of q is 2x plus x square cot x. So now we just need to calculate this integral to find the general solution of the differential equation. So we write y sin x is equal to integration of 2x sin x dx plus integration of x square cos x dx. We just separate the integral into two terms. Now we have to find this we have to integrate this both term. So we apply the product rule by parts to find the value of integral, and the by parts rule is integration of uv dx is equal to u into integration of v dx minus integration of du by dx into integration of v dx dx. So y sin x is equal to sin x into 2x square by 2 minus integration of cos x into 2x square by 2 dx plus integration of x square cos x dx. We just apply the by parts rule. Okay. We get y sin x is equal to x square sin x minus integration of x square cos x dx plus integration of x square cos x dx plus c. So when we simplified this term, the second and last term is cancelled out. We get y sin x is equal to x square sin x plus c. So now we calculate the general solution of the given differential equation, but we have to find a particular solution according to the given initial condition, and that condition is y is equal to 0 when x is equal to pi by 2. So to find y, we just substitute this value to get the value of c in the general solution. That general solution is y sin x is equal to x square sin x plus c. So y is equal to 0 and x equal to pi by 2. So as sin pi by 2 is 1, so we get 0 is equal to pi by 2 whole square sin pi by 2 plus c. So we get c is equal to minus pi square by 4. Now substitute the value of c in equation. Y sin x is equal to x square sin x plus c. To get particular solution, we have y sin x is equal to x square sin x minus pi square by 4. So the particular solution of the given differential equation is y is equal to x square minus pi square by 4 sin x, where sin x is not equal to 0. Okay. This solution is valid only if sin x is not equal to 0, and that is your. So to get a particular solution, at first we have to calculate general solution of the differential equation, and then by using the initial condition, we calculate the value of c, and when we substitute the value of c in a general solution, we get a particular solution for that differential equation, which satisfies the given differential equation as well as the given initial condition. Okay. Now example 18 is Find the equation of a curve passing through the point 0, 1 if the slope of the tangent to the curve at any point x, y is equal to the sum of the x coordinate and the product of x coordinate and y coordinate of that point. Okay, so in this example, we have to calculate equation of the curve. That means a solution, a particular solution, which also passing through a point 0, 1. That is your initial condition. That is x equal to 0. Then y is equal to 1. Okay, so in this question we have to calculate a particular solution, and in given initial condition is x equal to y is equal to 1 when x equal to 0. Okay, now the second line is if the slope of the tangent to the curve at any point x, y is equal to, so as we know, the slope of the tangent is given by dy by dx. So dy by dx is equal to sum of the x coordinate and the product of x coordinate and y coordinate. That means dy by dx is equal to x plus xy. Okay, so now you have a differential equation, first order linear differential equation, that is dy by dx is equal to x plus xy. So we can solve this differential equation by a method of linear differential equation. Okay, so at first we find a general solution, then by using the initial condition, that is the condition is the line is passing through 0, 1, we calculate the value of c, and then when we substitute the value of c into the general solution, we get a equation of curve which satisfy your general satisfy the differential equation as well as passing through the point 0, 1. So as we know that slope of the tangent to the curve is dy by dx, therefore dy by dx is equal to x plus x into y. Why? Because it is given in this question that the tangent to the curve at any point x, y is equal to the sum of x coordinate, so x plus product of x coordinate and y coordinate, so dy by dx is equal to x plus xy. So we get dy by dx minus xy is equal to x, and that is standard form of first order linear differential equation of the type dy by dx plus py is equal to q, where p and q are either constant and function of x only, but in this case p is minus x and q is x, both are function of x only. So now you have a value of p, so we can calculate integrating factor, and the integrating factor is given by e the power integration of p dx, that is minus x dx, and the integration of minus x dx is minus x square by 2, so e the power minus x square by 2. Hence the solution of equation is given by y into e the power minus x square by 2 is equal to integration of x into e the power minus x square by 2 dx plus c. So now you have to calculate the value of integral x into e the power minus x square by 2. Let's suppose it as I. So I is equal to integral of x into e the power minus x square by 2 dx. So to evaluate this integral, we use a substitution method, and we substitute minus x square by 2 as a new variable t. So let minus x square by 2 is equal to t. So when we differentiate it with respect to x, we get minus x dx is equal to dt, that is x dx is equal to minus dt. So on putting the value of x dx, that is minus dt, and minus x square by 2, that is t, in integral I is equal to integration of x into e the power minus x square by 2. We have I is equal to minus integral of e the power t dt. We just replace minus x dx by dt, minus dt, and put minus x square by 2 as t. So now we have to integrate. We know that integration of ex dx is ex, so just use this formula. We get I is equal to integral of et dt, that is e the power minus e the power t. So just substitute back the value of t, so we get minus e the power minus x square by 2. So substituting the value of I in the equation, we get y into e the power minus x square by 2 is equal to minus e the power minus x square by 2 plus c. So y is equal to minus 1 plus c into e the power minus x square by 2. We just rearrange the equation, and that is your general solution of the differential equation. So now we have to calculate particular solution according to the given condition. As this represents a family of curves, equation of family of curves, but we just need a single equation of a curve which also passing through the point 0, 1. So we just use that condition. So we are interested in finding a particular member of solution passing through 0, 1. Therefore, just substitute x equal to 0 and y equal to 1 in this equation. So y is equal to minus 1 plus c into e the power x square by 2. So we get 1 is equal to minus 1 plus c into e the power 0. So c is equal to 2. So now we have value of that arbitrary constant. So we just substitute this value into the general solution. That is y is equal to minus 1 plus c into e the power x square by 2. So we get the required equation of the curve, that is y is equal to minus 1 plus 2 into e the power x square by 2. So that is your equation of a curve which passing through the point 0, 1 and also satisfy the given differential equation, that is dy by dx is equal to x plus x into y. Okay. So in today's class, we just see what is your linear differential equation. It's two forms, first another form, and then we just see procedure how to solve a linear differential equation. Okay then, thank you.